I made the template.
Oh my God.
Time run. So I made the template, and I will explain everything through.
Can you guys hear me?
And applying it would be pretty cool.
I cannot hear anyone. Hello.
We can hear you.
We can hear you, yeah.
Hello. What happened? Strange. Hello.
Hi.
Hear us now?
Can you
hear that better?
Now it's working. This strange morning today. Sorry, guys.
No, it's okay. We were just saying we've made some good work so far, and we're going to present it. And Salman was just saying he's made a nice template for what he was working on, and you can show us the bits and bobs, because I think me and Salman have taken slightly different approaches, and I think pulling them together and seeing which ones, because the ones I've done are more. They're like your sort of immediate decisions, and they're the sort of ones that you do straight off the bat just to see where you're up to in terms of the data, where Salman is done it quite progressively, where that's a real drill down into the detail more than what I've done. So I think, when it comes together by the Wednesday, we'll have a fantastic preparation for the model building side. So,
yes, that was the whole idea, because we talked about that which direction you were going. So I thought, why not I explore a different direction, and this way we would be covering different things, and why not then?
Yeah. Well, the template you uploaded, I was looking on your GitHub because I got a notification for it, and it's superb. So I'm looking forward to see the results. I was gonna start presenting, Imran. Could you allow me to present, or do you need to update with anything at all before I start?
Probably in the end. I guess you guys are a priority today. So
cool. Okay. Just give me 1 second. Screen one. Can everyone see my screen now?
Yes.
Yeah, cool. So I sent a message into the group earlier, I think it was yesterday, and what I've done, the very first sort of presentation I put together was the data, which was just imputed, scaled, well, that was it, imputed and scaled, and I put that data together, ran it. I didn't remove any columns or anything like that, took no insights from the EDA whatsoever, so we could sort of benchmark our results. This time round, I uploaded a new data set, and this was taken with a couple of insights from the EDA, not all of them, because I expected other people to sort of play around with what sort of options there was in the EDA section. So I done a few, and I also combined a couple of columns based on on my own experimentation, and I think it's produced quite interesting results compared to the other one, but nothing too drastic or too complicated. I'll just crack on and show you what I've found. So this is all just stayed the same. I've just renamed the data set as the EDA train data, and that's available on the GitHub. Anyone can download that and import it to their environment. So let me just explain what I've done. I've took a list of columns, and as you can see, as Salman did in the EDA, he split them down into a couple of different columns, and I think what we'll see later on is that actually has become quite valuable in terms of the importance of the features. I think grouping them into 4 categories that was initially done, I think it didn't give it didn't really provide the data with any depth. While this one, you'll notice that these are quite strong features now. So I'll get onto that in a moment. I took the feature that Salman suggested, scaling it was just the age. So that was the present date minus the year of the building being built, and I dropped the year factor column and replaced it with the age column. In the Q1, Q2, Q3, and Q4, what I've done is grouped months together by 3 quarters. So 3 months equals a quarter. And what I've done was take the average temperature for each of them 3 months. So I combined them and took the mean and put it into its own column called Q1. And then I dropped the rest of the temperature columns just to see what, how whether that increased the importance, whether that increased the or reduced the coefficients on them, and I'll get to that in a moment. As you can see, I've dropped the rest of the temperatures, and I dropped also the wind speed just to see how that would affect the model, but I left in the temperatures here because there was a couple of these which had a strong correlation according to the EDA. Especially days with fog, that seemed to be one that stuck out. So in terms of the VIF, if you remember from the last data set, which was just the imputed and scaled data, there was some of them with astronomical VIF ratings. But since I've messed around, there's only a couple now which seem to have extremely high values. And you might notice this one has a nan. Now, that is because this one is so far off the chart that it just causes a statistical error. So that one, we know, it doesn't even compute a value. So that one can, according to this, can be dropped straight away. If you remember from the VIF as well, I've scaled them. Sorry, I've sorted them into ascending order. So we've got all the ones here, and according to VIF and the sort of theory behind it, if anything below 5 should be fine to go forward within a model. So as you can see here, there's a couple more there's a couple more in this particular data set than we had in the previous data set. And if you notice, some of them are the sort of the building facilities that have been regrouped again. So I think that was a very positive move that we put together in the EDA, and it has created quite an interesting result. So anything beyond here, according to this VIF, we could drop them. We could do it. It's a very simple way to do things, but it might not be the right things. That's why we have to do a couple of different options just to gauge what we're doing. And as you can see, splitting them into quarters, it's reduced some of them, but it hasn't really done much. It hasn't really given much weight to our model whatsoever. So that might have, to be reconsidered. Is there another way of doing this? I think Salman suggested that we could leave in the max temperatures or the minimum or both. We can experiment, and hopefully, someone has tried to do something similar to this, and we can discuss them results. But what I did wasn't really effective whatsoever. But that's what the name of the game is. It's trial and error. What we've got, so that's just a graphical representation. And I've just explained why the scale for days above 110 Fahrenheit. That one is just because it's just caused a statistical error because it's that it's that beyond it's so much of an outlier that it can't even comprehend a computer value. The feature creation, again, I haven't gone. Sorry, Salman, were you saying something?
Yes. So this particular column, it has only one value, so it's easy. We can just drop it. Means in EDA, I think I dropped it, but yes. So it's just one value. We can drop it right away. Yeah.
Well, that's the thing with the VIF as well. It's a powerful algorithm, and as Salman said, if that was one column, that's why it's caused that, because it's got no variance whatsoever. So it just can't compute it. I'm going to also as well, I'm going to do a little write-up in a little bit more depth about how this is calculated, because I only went over it briefly here, but I think it's a valuable tool to have when you're doing feature engineering. So I'll go into a bit more depth about that. Other than that, the feature creation, that's what I did. I combined the monthly average temperatures into seasonal columns, but I went with just called them Q1, Q2, and ordered them January, February, March into Q1, and so on and so forth. Now, I added this correlation map here. I think just because I was rushing ahead a little bit, I forgot to always check back to your correlation chart just to see where you're up to, especially when you've created new features. It's always good to go back and double check any sort of correlation whatsoever. And as you can see, compared to the EDA correlation, there has been some differences, especially around here, especially around the new columns. But as I say, don't seem to be very effective. So I wouldn't, I wouldn't really. I'd think of a new strategy to do with them temperature columns, because intuitively you would think the Energy Star rating would be related to you know, the atmosphere, the temperatures in the atmosphere and things like that. So that's one that needs further explanation. If someone's done it, that's great. Okay. As previously, the light gradient boosting machine. Since I've messed around with a couple of the columns and done some experimentation, to be honest, there isn't much of a drastic change here. As you can see, the age here, that is a very strong feature. Some of the features strength has dropped a little bit, but that's what happens when you're doing feature engineering. When you remove features from your model or combine or create new features, it does have a knock-on effect with other features, and that's what we can see from the chart here. Generally, these features have stayed the same in terms of importance, but the values of importance have changed somewhat because it does have a knock-on effect. The XG boost is exactly the same. There's a bit of a more clear-cut gap here, which we didn't see in the previous version of the data set. So that is quite interesting. So, you know, that might make it a lot easier. If we go for the XGB boost, you could probably just cut these features out and still have quite an efficient model. But, you know, it's just made it a little bit more clearer. As again, nothing has really changed drastically. I was surprised to see a Q1 here though. So January, February and March average temperatures, they seem to have quite an impact according to this particular decision tree. That might be worth more investigation. It might be an idea once it comes to model building to test them out, test all these models out and just see what the influence is, because I was quite surprised to see that there. That is definitely an interesting one to explore if you're going to use a gradient boosting algorithm. And I also added the decision tree regressor. And this one, it's pretty much the same sort of story, but as you can see, the XG boost it makes the you know, a gradient boosting algorithm gives a much more profound sort of grouping than the decision tree. But what I'm going to do with this one as well, there's an inbuilt function in decision trees where you can visualize the actual decision tree, so you can see how it's grouped the features. I'm going to import it. I just didn't have time today to do it, but that's what I'll do, and hopefully by Wednesday it'll give a more intuitive look into how this particular decision tree regressor works and how it's grouped the features in a visual way. But it's, you know, there isn't a massive difference between this one and the gradient boost one. It's just that the gradient boost ones give it a much more, you know, defined and much more coherent sort of grouping, which I'll show you visually. The principal components analysis, it has changed slightly. The curve isn't as steep. So what we said in the last one was 12, I think it was 12 features compose about 86% of our data set. In this particular model that I've built with some of the insights from the EDA, it's seen that 12 only done about 10%. 12 features only did about 80% of our model, so it's decreased a little bit. So I was just messing around with it, and I tried the 10 and just seeing what sort of results it pulled out. What I did notice though, the strongest feature was actually 29%. In the previous version, it was 28%. It just seems that it has had a negative knock-on effect for dimensionality reduction for the PCA. That's what I found, and as you can see, I've just messed around with the number 10. I just threw it out there, and these are 10 features that explain about 75% of what our data says in this particular set. So that was pretty much the difference between the original data set that hadn't been edited and the EDA data set. You know, the EDA, we found a lot of good insights, and I just randomly selected a couple and went with them. Done a bit of experimentation on my own, and this is what I found. Would I say it's very strong? Probably not. But it does give us some key insights in, you know, what features matter in our model. And I think the best sort of, out of everything I've done here, the two gradient boosting algorithms, the light one and the standard XG boost, they're probably the strongest ones to take forward. And I would probably take these features and try and experiment with the model, paying particular attention to Q1 because I thought that was a very interesting result. However, before I do any of that, I'll probably work on the VIF and remove all the high ones and keep all the ones that fall below the value of 5, rerun it again, see what happens. And I think, you know, that might be an interesting way forward. But, you know, I'll have a look at them results by Wednesday. I'll produce it before Wednesday, and I'll put it to the Slack chat and just let anyone, you know, take a look and see what they've come up with. But yeah, if anyone's done anything differently and come up with better results than I have, you know, please let us know in this call, and we can take a look if you've got it if you've put it together in a collab. But other than that, I'm happy to pass over to you, Salman, just to show what you've been doing.
Sounds good. Thank you. Okay. So
just before Salman gets on, is anyone got any questions about anything I've done at the moment? No, silence is golden. Over to you, Salman.
Okay, so what I tried is, so I would be explaining using a template, because I think that it means that I kind of like did something other extra than what means I could have applied on the data that we have, and I could have just showed you the results. But I want you to understand how it works, because majority of you, I am getting a lot of questions privately on Slack. So I thought that I should go deep down and explain how it works, what is happening under the hood and things like that. So what exactly this recursive feature engineering? So what Rich, all the things that Rich presented, they are one way to do feature selection, but there are several others. For example, the simple coefficient method. For example, we know that a regression equation, a simple linear regression equation, is y equals mx plus b. That means a coefficient multiplied by a feature plus the y-intercept. That means if, for example, we have multiple features, and what we do is basically when we run the linear regression model, it figures out what should be the coefficient we should multiply with every single feature in order to get a particular line or line of best fit. So if we scale down all the features at the same scale, for example, like if we standardize all of them up, all of the features have the mean value at 0, and their standard deviation is 1, which means this way we can compare every single feature with each other, and they are not bigger or smaller than each other. So when you run the linear regression model, what happens is it determines the coefficients that it would be multiplying with each feature. So if the coefficient is big, that means that particular feature is more important than the one which has the least coefficient. So what I did is basically I kind of like applied it on a simple linear regression model. So I pulled in a basic simple linear regression data set from sklearn. So sklearn has some built-in. So this one was a pretty small one, and it is just for linear regression, just numerical variable. I don't have to do anything else. So this is just a template. I would be applying this whole thing on our data, and I would be showing the results. In fact, I have already applied it. When we were doing data pre-processing, I already applied RFE, means I applied like GBM, I applied RFE. So that RFE I have already applied, but I would show you how exactly it works. So if you see over here, this particular data set has 442 rows, and only it has 10 features. So it is pretty small. So it was easy for me to play around with it, and no more cleaning or encoding or imputation was needed. So just to understand a bit, I just picked up the clean data set. So then what I did is I looked at the head of the, so you can see it is a diabetes data set. That means it has some columns which are predicting diabetes. The Y was just the value of the diabetes or something. So then a bit of pre-processing. What I did is I basically break it down into train test split and standardized it. So after standardizing it, I think last time Vandana was asking about when to do scaling, or whether we have to scale on the complete data or only on the trained data or something. So we would get to that point, but for now, just I will explain. I only transformed or fit and transformed the train X train. I did not. So that means I fit the sender shader only and only on the train one, which means I would be using this for any of the things that I would be doing later. That means for X test, I would not fit the scalar again. I would use the already transformed fit one from the train test, and I would apply it on the test set. So when I did that, I made a simple linear regression model. So when I made a simple linear regression model and I predicted the results, my results turned out to be these. So this was my R-square value, mean absolute error, and mean square error. So this is one thing. Then what I did is I figured out the coefficients. So when I figured out the coefficient, these are the coefficient values for every single feature. So you can see that some of the values, so 0.929 is the smallest value, which means I can go and I can try kicking this particular column or this particular feature out and run the linear regression again and match the results that I got here. If I'm getting the same results by kicking out one of the feature, that means that feature is not as important. So that's what I did. So what I did is basically I created a data frame. So this is a feature versus importance data frame. I just converted this particular list into a data frame so that I can play around with it. So this is kind of like the same thing I transposed. And then I plotted it. You can see the importance is being plotted here. And you can see age has the least possible coefficient in this. That means if I kick out age, that's what I did. Next time, I just kicked the age column and then rerun the linear regression all over again. So when I rerun the linear regression all over again, you can see the errors, they are pretty much same. You can see over here, the errors were 0.519 R-square error. Here I'm getting 0.520. That means pretty close, 0.519 and 520. MAE value 41.940. You can see over here, it is 41.970, pretty close. MSE value 2972, and it is 2965. That means pretty close. That means that age column, even though I dropped it, that means I made my model less complex, but the accuracy is still not affected. So which means this is one way to do it. Now you must be asking, our data has 60 variables, right? 60 plus features, which means if I start doing it manually 60 times, that would take up a lot of time, right? There should be a quick way to do it. That's where recursive feature elimination, RFE, comes into play. So it does this whole thing automatically. You just tell it when to stop and it will keep on dropping one column at a time. Now, one important thing to know here. So if you look at the importance values here, right now, when I did not drop it, it has different values. Just what Rich was saying, that when you drop a particular column, it changes the importance in the next run for all the other columns. So that is what happened here as well, which means if you are dropping more than, you must be saying that why I'm doing it 10 times, why I'm doing it 60 times, why not just drop all the columns which have the least importance in one single go? Because if you drop one column, it's going to change the importance of all the rest of the other columns if you rerun the whole thing all over again. And that's what I wanted you to see. Over here, the importance is something like this. You can see, for example, this sex column has 13.13, BMI column 22. Let's see by doing or rerunning it. Did it change? Sexes is still 13. It was 13.13 and now it is 30. Not much. BMI is still 22.2, but some of them did change a bit. BP is 14.4, so it is 14.6. You can see the values are slightly changing, and that is a big difference. So in some cases, it would be pretty big. For example, S6 is 4.54. Over here, the S6 is 4.54. Not much big difference, but you can see there is a difference. That means in some cases, the difference would be pretty huge. So, and we don't want to take that risk. RFE comes into rescue in this scenario, and we can do this whole thing very accurately. And so what I did is basically how to run RFE is simple. You call the RFE from the sklearn. So, and then what I did is basically I made a pipeline. So what is a pipeline? Pipeline is basically if you want to do several steps one after the other, what you can do is you can make a pipeline and use the pipeline as an input to certain things, means anything that you want. So what it does is basically when I put a pipeline over here, for example, I created a pipeline here, it calculates the RFE first and then creates a model. So what I did is basically I run the RFE first, dropped several columns using RFE. Once I have all the dropped columns, then I created my model all over again and predicted my model and trained my model all over again. So I didn't want to do it in two separate steps. I just created a pipeline. So in a pipeline, it is doing automatically one after the other. First, it is running the RFE, dropping all the unnecessary columns. And once we have dropped all the unnecessary columns, whatever data you are left with, you are just training your data on training your model on that particular data. So it kind of like does that. Now, this is something I can double check. So I did the K-fold cross validation. So cross validation is important because I want to see whether if I'm dropping some columns and everything, it is giving me good cross validation. So I rerun it and divide the data into different folds and repeated it several times to check whether the error I'm getting is consistent. So we got the error over here, and for example, MAE error is -44. Don't mind this negative because in the scoring for cross-validation score, it picks the negative value because what it does is so remember, mean absolute error should be positive, but here it picks the negative value because it kind of like shows you all the errors ranging from -infinity till 0. That means if it is close to 0, it is the least error. So it's kind of like just because of that, it kind of like creates. It does not accept a positive error here. So we need to go with negative, and don't mind this negative. If you want to create a positive here, you can just take an absolute at the end and it would give you positive answer. But right now, don't mind this negative that we were getting a positive error, but why we are getting a negative error here. So don't mind that. So you can see that when I run this whole thing and I got it. Over here, I'm selecting 9 features. But how do we know how many features to select, right? So I don't know which features would give me best answer or best result. That is where Rfe Cross Validation comes into play. So what is Rfe Cross Validation? It is a cross validation version of Rfe. Instead of running Rfe, what you can do is you can run okay, so you can run. So here you see that instead of Rfe, I use Rfe CV. What it does is basically it figures out how many features are optimal or will optimize my result. So what it does is basically I repeated the whole thing. Instead of Rfe, I use Rfe CV. So what it does is basically it picks up. So over here, in the decision, I will talk about it later. Right now, just focus on this. So you can see that it figured out the optimal number of features. That means out of 10 features in this particular data set, 2 features are optimal, which means if I drop 8 of them one by one using Rfe, because previously we did not know, now we know that how many features are going to give us the best result. So it is giving me 2, so I would just go by 2. And that is what we are going to do. So when we are doing feature selection, we have 63 plus, we can do this Rfe CV and we can figure out how many of features we can drop. And that way we would have an optimal number of features, which can give us a very good model. So that is one way to do it. Now, here comes the multiplication part. Multiplication part means now how many different things you can do here. The thing you can do here is this estimator. This estimator can be anything. I used a very simple estimator, decision tree regressor. Decision tree is just one decision tree. If you want it to be more efficient, just use a random forest or gradient boosting or XGBoost or light boost. Any particular algorithm which kind of like calculates the features or selects the features as a built-in function into it, you can use it as an estimator over here. So I can use my simple linear regression model, logistic regression if it was a classification problem. So I can use a random forest here. I can use a light GBM. I can use a simple GBM. I can use XGBoost. I can use there are so many others. For example, like I can use simple perceptron or neural networks or whatever I want to use. So which means we can find the feature importance using all of those models, put them in one single data frame, and then what we can do is if we don't want to trust one of it, or if we don't want to trust 2 of it, what we can do is we can do voting at the end. So what voting does is basically we can set that. So they are assigning feature importance to every single feature. For example, like let me show you what I'm talking about. So this is from our first data preprocessing. Here you can see that I put the ranks in 2 different columns of a data frame. So what we can do is we can find the feature importance using all the different methods that we are doing and putting them in a data frame. Once we have, let's say 10 columns, we have tried 10 different strategies. So what we can do is we can do a voter. And what does voter do is basically we tell it a threshold that if this particular feature is getting more than this number of votes, then we should keep that feature, otherwise drop it. So we can make a mask using the voter, and then you can use a mask to drop all the unnecessary columns, and then you have an optimal number of features that you have selected, and you have kind of like used several different algorithms to select the features, which means every single algorithm has its own drawback and positive things. Which means when you are combining all of them up together, you are kind of like using all of their benefits so that they can overcome the drawbacks of the others. So that is one strategy. I would be implementing it, and I would be showing you at least 10 different varieties of it. That means I would be showing you individual results, and I would be showing you the voting results as well. So and we can then after that what we can do is we can do the PCA on individual 10 different columns and see what the elbow curve for the PCA tells us. And we can compare whether PCA, we should go with PCA, or whether we should go with the voting one, or whether we should go with one specific one. So we can try that. So we would have a lot of different you can say feature selection ideas and feature selection algorithm that we would be implementing. Rich is implementing the feature based on the tree methods and everything. And VIF is something I have never implemented, so I'm learning from Rich. I have no idea about it. But these things are what I would be implementing. And if anybody has any question, I would be uploading this template for anyone to use. It is a step-by-step one, which means if you want to understand what is happening, you can go through it. Or if not, then you can always go at the bottom and copy this whole thing. This particular chunk does the everything. So this is the template, which means if you want to run it to any, and go ahead and change this particular estimator, and you would have random forest. If you want to change it to light GBM, just call in light GBM here and run it through light GBM. If you want to do it gradient boosting, just call gradient boosting and run it through here, and you have your answer, which means it's pretty straightforward. Now we have the template, just put it in our data and put in the X-train and whatever. So you don't even have to change anything. If you want to change with the scoring criteria, it's up to you. You can play with it. You can maybe, instead of mean squared, you can use mean squared error instead of absolute error. Yeah. So I think there was a question, Imran, in the chat box. I did not.
Yeah.
Do you know what was the question?
She just said she's a question, so
yeah,
let her ask now.
Okay.
I was asking, my question was regarding RFE. So
Mm-hmm.
you have provided as an argument like number of features.
Can you speak out loudly, please? No.
Okay, is it audible now?
It's better,
Still
but
quite low.
very low. Yeah.
Okay, so I was asking regarding RFE. So you have provided as an argument like number of features to select.
Mm-hmm.
So you have provided in that 9 features you want to select, right? But when we are running RFE CV, so out of that, like we need to select only 2 important features.
No, RFE CV does not. RFE CV tells you 2
Okay.
features would give you the optimal result. So because this is part of hyperparameter tuning, which means any particular parameter that you are setting originally to get a feel of the whole thing, and then you don't know what number. It's kind of like the alpha value for or learning rate for lasso regression or something like that. So it's kind of like that. It's part of hyperparameter tuning. You need to optimize how many features to drop, or because I started with, let's say I want 9 features. I want to keep 9 features. but I don't know how many features would give me an optimal result. So I need to do the whole cross validation thing. So Rfe CV gives you that option where it tells you that if you go with 2 features, then it would be the best optimal results. So Imran, if you show me, give me access to the screen. I want to show a graph which shows you the importance of every single, if we drop 1 feature, then what would be the error? If we drop 2 features, what would be the error? And things like that. So for example, let's go at the bottom. So here it is. You can see that here I have plotted the graph, and this graph is telling you that. So if you look at the error over here, so this is getting smaller as it goes up. So it's kind of like upside down, the y-axis. Don't get confused that the error is getting increased. No, error is getting reduced because it is upside down the y-scale. You can see when we have 2 features, then we are getting the least amount of error. That means the cross validation thing, Rfe CV, it tells you, it runs this whole thing. It determines what would be the error at every single, by dropping every single feature. And then it calculates the error, and whichever is giving you the least error, it tells you that this many features give you the least error. So that would be the optimal number. So you can determine that particular number this way. Yeah.
Okay. Thank you.
Anybody has any other question, please go ahead. Okay, one more thing. Here I used another library, which is called Yellowbrick. Yellowbrick is a different version of sklearn. Now, what it does is basically, instead of me plotting, writing a lot of code to graph this particular thing, this one automatically graph it for us. Means it has the same functionality. It is kind of like built onto sklearn. It is using all the features for sklearn, but in the background, it is kind of like doing extra steps for you to kind of like do visualizations or things like that. So here what I did is I used the Yellowbrick model selection and Rfe CV, and it is running it. And finally, it doesn't tell you. So you cannot extract much information from it. If you want the information, you have to use the sklearn Rfe CV. But if you want the graph, it would give you the graph in one single line. Means you just fit it and you just show it, and it's going to show you the graph. So you don't even have to do the matplotlib things or anything. So it's straight away. Yeah.
Yeah, it's a powerful model, and I think it's essential to use that with what we've already got as well. It's just another way of doing things, and it's a much more automated and methodologic. Can't say that word. But it's a much better way than doing it manually. And it's good to see that we've got 2 sides of the journey as well. We've got the ones that are like your sort of go-to, your go-to algorithms that give you a good understanding of the data and what's not important. And then if you run it through that, I think the RFE really drills down of what is important in an automated way, which is you can let the machine decide what's important to it, and that's why it's very powerful. So yeah, it'll be good to sort of cross validate what we've already got with this, and then we can move forward then with the best output. Yeah, fantastic. And as it is in a template form as well, anyone can pick this up and input their own data. So if anyone's got any other insights or experimented with the data set after the EDA phase, plug your data in and let's see what we get, and then we can discuss and move forward. I like it. Very good work, Salman.
Thanks. Very, very good work, both of you. Actually, you guys complement each other. Actually,
yeah. I think we form a good team because our communication is good. We kind of like tell each other what exactly we would be covering and what our thoughts are. Which means if it is overlapping, we try to go at least cover a different section so that we can bring in more information or more kind of like things.
Yeah. Yeah, there's no point in just doing the same tasks up, all of us. It's like you take that angle, I'll take this angle, and then we'll meet in the middle again. So yeah, it's we've done some good work, I think, over the past couple of tasks. I really enjoyed it.
Definitely. I'm just curious, Salman, this Yellowbrick thing, I never heard of it. From where did you find out about it?
Google.
Okay, well, you need to know something. What to search for, right? I mean, okay, that's interesting.
Means it's kind of like I was searching Rfe CV and how to kind of like graph the cross validation results of every single validation that it has done or something like that. I tried several different keywords, and then Yellow Brick kind of like came up. I just explored it and then followed their kind of like tutorial. So on their website they have a step-by-step tutorial of one example. I just picked their example and put it on in our template. Yeah.
Nice. These codes you literally type, or is this something any website you just pick and then you just have a template or pre-written and then you bring it?
No, this whole thing I have typed myself. Yes, I'm using bits and pieces from different websites and different things. I have several different books open in front of me as well. So I'm kind of like using their ideas and arranging them in a way that I can understand. So I'm just creating kind of like a template which would be easier for me to go through when I want to go through in future or something. So it's kind of like my dictionary. I'm creating my own dictionary. Yeah.
Perfect. Yeah, once these templates are created for different models, I mean, once you know where to approach, I guess it really helps down the road.
Yes.
Yeah,
for sure. Okay, any
definitely.
questions?
I think my whole career is now a template. I just, if there's a problem that I have to face, I've got a template for that. But you know, the hard work, the initial hard work, does pay off. You know, you don't want to be typing the same thing over and over again and trying to remember everything.
I was not creating a kind of like a complete repo. So I saw Rich doing it. So he kind of like he made a complete repo where he's keeping all his templates. So I was not doing that. Yes, I have all the templates, but they are kind of like on my computer, sitting on my computer, not arranged in a particular way. So now I'm creating my own GitHub repo where I'm arranging everything by the names and what kind of what type, whether it is feature selection, whether it is regression, whether it is classification or something. So because that is a good tool, you can always reach out anywhere you are, not on just your computer. You can kind of like go through it. It's kind of like your own library.
And that's the thing. It's not a competition either. Everyone, you need to share knowledge, and it's good to share your knowledge, and it's good to see other people sharing theirs. So if I made them templates for me personal use, but if I can share them and help someone along the way, or help someone understand something a bit better, or even have someone correct it for me where it might be wrong, you know, great, let's do it. So that's why I share mine, but it's just good practice. And yeah, the Rfe template here, I'll be definitely stealing this one, Salman. I'll be definitely stealing it.
You're gonna post it later, right, Salman?
Yes, I will post it. But this is already on my GitHub. But I will apply it on our project, and I will be posting that. Yeah.
That will be helpful. Thank you a lot. Thanks a lot. Actually, I'll be interested to dig deep into this. But yes, Rich is, I really like how he organizes codes over there. Something I also learned pretty much. I'll be creating more templates of mine. Okay, any questions, anyone? Please feel free to ask. Nobody's going to judge.
So a question, by end of this phase, like by Wednesday, are we going to finalize that? That's the model that we are gonna use further, or there'll still be more trial and errors in the next phases?
I think but at the end of this stage, we've got a number of different ways to organize our data, and we've got a number of different ways to check out feature importance. I think what a good way to do, because for the sort of model building and things like that, I've got a script that basically checks a data set against a number of different regressions. So I think what would be a good idea, if we pick 3, so we pick the results from the Rfe, the results of the XGB boost, and the results of you know, the PCA, and if we save them down into 3 separate data sets and run them through the models, we can then decide which is the most effective. That is something that I do in real life. You know, it's very difficult. You know, you could spend months and months trying to figure out something like this. But as Salman's got on his screen at the moment, that's the code that runs the data set through a number of different models, and then you can gauge which ones are more accurate and which ones you could use and which ones you can sort of put to the side. if we have three, if we can't decide between a couple of, if we can't decide between a couple of ways of doing it, why not try them all? Do you know what I mean? And then we can just decide which we're getting the best performance out of, and using that for the real life deployment.
Yes.
Does anyone agree or disagree with that?
I would want to add. So it's kind of like making a model is the easiest thing to do. Means is the easiest thing to do. There are just two pieces of code you can copy paste. For example, if I show you, there's one piece of code, you make a pipeline of all the models that you want to run. Then make a grid of all the hyperparameters you want to try on those models, because there are so many hyperparameters you want to try several different. And then you just run the grid search CV and it's gonna. So these three pieces of code can give you can put any number of models in it, and it's gonna give you the results depending on how big your data is and how much processing power it is using and everything. Depending on that, it's gonna give you results. If the data is pretty small, it's gonna give you results in 2 minutes, which means the model development phase is just 2 minutes long. But it depends on how good data you are putting in, and we don't know which strategy is going to give us the best result.
Yep.
So since we have created a lot of strategies, what we are going to be doing while making the models and everything, we would be trying hit and trial all the different data we have processed in different possible ways. Maybe this way would work, maybe this way would work, maybe this way would work. So we will try all of them up and run it through our whole template for the all the models, and we will pick up the best model based on that one and just pickle that model and keep that model for the future or something like that. So model development is just 2-3 minutes long. That's it. Or you can just add the processing per time in it. Other than that, just 2-3 minutes long. Copy paste this particular template and you have your model. But which data you want to put in, you don't know. Which one would give you the results? So at the end, we would have developed several strategies by the end of this phase that we can try for our model development phase. So when we are making model, we can try this strategy, Rfe strategy, feature selection using tree methods, or VIF method or PCA method. We tried several different encoding things, different imputation techniques. So we can hit and trial, because that gives you a lot of different hyperparameters along with the hyperparameters of the model. So you don't know which imputation would give you the best result, which encoding would give you the best result, which feature selection method would give you the best result. So we will play with all of them up and we would compare and we would see which is giving you best result and just stick with the best result. Does that answer your question?
Yeah. So after end of every the model or feature selection method that we use, we will have a different data set, right?
Yes.
Yeah, there's going to be a number of data sets, each one with its own benefits, each one with its own negatives as well. And as Salman said, we're just going to run it through the model selection algorithms that he's put together there, and just decide which one gives us the best result, and then we can take it forward. Then it's just a easy and sort of economical way to do things, I think.
Yeah.
Any other questions? Anyone?
No. Has anyone got any insights to share as well? Anyone been doing any experimentation with the data themselves and come up with anything different to what we've found?
So, and the book chapter that I shared, a lot of stuff that we covered, me and Rich, is in that chapter. So we did not cover everything. Feel free to go ahead and try other things from that book chapter. Means I find that book chapter means I was keeping that book chapter in front of me when I was implementing. I was reading the theory. I had several different other books, and there was one course I did from Data Camp, which was technically about feature engineering. So that course was amazing. Means they had very good kind of like the person who was kind of like doing that course is amazing. He gave very good insight. The voting idea I got from that particular course. So he showed me, he showed in that. So he applied it on a classification model, but we can apply it on a regression model. It doesn't matter. But I got the idea from it. So what you do is basically when you are kind of like studying, just read every different blog articles. Mastering Machine Learning, I shared with you with Jason Brownlee. That blog, he has a lot of stuff with full written code in it with step-by-step explanation. So I would recommend you read his blog for any topic, because he has been writing for so long. He has created, I think, more than 15 plus books. So from just using his blog. So which means he has a lot of stuff. Anything that you want to search about machine learning, you would find it on his blog. Just one person who is writing everything. So it's kind of like if you read anything and if you like it, every blog would be just like that, because he's the person who's writing it. So I would recommend read different books, read different blogs, read different person's ideas, and to combine those ideas and kind of like try to apply them. If you don't apply them, you're not learning. I'm telling you, you will forget about it in 2 days or in 3 days maximum if you don't apply it. So I would recommend you start typing the code yourself. Don't copy paste. Even if you are just copying and pasting from it, don't use copy paste. Type it with your hand. That makes a big difference. I'm telling you by experience. I started seeing a difference when I started typing. Yes, I was taking notes. For example, if you see, I was writing everything down. I don't think you can see. I was writing everything down by pen. But yes, that's one way to learn, because I learn better when I'm writing with my hand instead of typing it. But what I did is I basically started writing with my hand. And then I, when I'm done with the course, took the notes and everything. Then I open a Jupyter notebook, and then I started typing in all the code in and seeing what exactly it is. So that kind of like reinforces your learning. So I would recommend anybody who is a beginner, trust the coding process. Trust what I'm telling you. I'm telling you with my experience that this is what helped me. So I would recommend you do it. And I have a neuroscience background. I know how neurons work, how learning works. I have created neural networks from ground up. Means I have studied a lot of, means I have a lot of theoretical knowledge. I can tell you, and I have been teaching for 12 years. I know that repetition has a very strong influence. I have seen students who do repetition, who do their homework regularly. They do way better than the students. Yes, there are some anomalies, some students who even don't do anything, but they are still good. But those are anomalies. Majority of the students who do their homework, they do really well.
Thanks for giving this honest advice.
I agree. It's the same. I do exactly the same. If I see someone's code, I don't just copy and paste it. I type it out so I get a better understanding of it if I'm actually writing it. But I'm one of them people. I love errors in me code, because that means I have to learn and how to fix it as well. So when I run something and it doesn't go right the first time, great, because I'm about to learn something. If it runs perfectly first time, I haven't learned anything. You know what I mean? So yeah, problem solving as well is a massive thing about doing this. So yeah.
It's definitely a good mindset. I really like both of your guys' mindset. Yes, definitely. And the more you face error, you dig deep more and you find out some new links, and that's actually enhance the whole learning experience.
Definitely.
Yeah.
I would like to add something.
Please.
Imran, so Rich and Salman, if you can share your learning path, I mean, from where you started, what are the courses you did?
Just
I'm doing it. Me and Rich, we both are planning to put our whole journey in a video form, and we are planning to put it out. So yes, we are working on it.
And also all the blogs. I mean, you have already shared enough content, and we're really thankful for that. But then, how you started out, because Rich has also moved from data analyst field to data science, and you also started somewhere. Like I saw your journey in
so far you can see I'm a teacher.
Yeah, so we'd like, oh my god, you are handling everything, you and Rich. So
but yes, I have educational background in it, but I don't have industry experience. I think that's why my theory is a bit stronger. My application is something I'm working on. Yeah.
So yeah, if you could, I mean, share it in a separate channel or all the existing any of the channel where in discussion or something.
Definitely.
Yeah, so we'd like to know everything. Thank you.
Yeah.
From my experience,
Not a
at least I know whenever you do good to others, good happens to you. May not be directly, but some karma works in your favor. So I like definitely support your guys'
Definitely.
mindset for sure. Any other questions, anyone? Any concerns? Okay, she wants to join as well.
She wants to get on the project.
So thanks everyone for those who signed up for presenting. Let me share screen. Right, these are the people who signed up so far. We just need 2 spots for one for EDA for continuous categorical stuff and one for feature engineering for dimensionality reduction, RFE and PCA. So feel free to sign up those who haven't. And yes, so we still have, please let us know by this coming Wednesday. Sign up your name. Otherwise, those who feel shy to present, we have another alternative for them where they can add value still and be considered as an active members. We are thinking that how about they create some README file for different tasks we are doing for data pre-processing, EDA, and feature engineering. And Salman can elaborate more on that, what exactly what we mean with that.
So
what do you mean by README and what they should be delivering in terms of expectations?
Sounds good. So if you let me share my screen.
Oh.
So for example, like if you go on GitHub and you look at any person's GitHub, you can see that, okay, where's my GitHub? Okay, so this okay, so you can see that this is the README file, right? So right now, if we go to task 1, yes, we did a lot of stuff, but I kind of like, we don't have anything here written in the README file. So what you can do is you can use the notebooks that we have uploaded. For example, like everything that is written here is in README format or is in Markdown format. Which means what you can do is you can organize the whole theory and the graphs that we have figured out. So for graphs, what you would have to do is you would have to kind of like go and write one line of code again to download or save it as a figure. So you can just kind of like write a line over here. After that, what did I do? So after that, you can just write that save underscore fig or something like that and write the name of the figure, and it would just save it as a figure. So save them as a figure and then put all the markdown written things that we have written over here in the readmes of every single task. So this way, we would have a very good README file in front of us. Anybody who is coming on our GitHub page, they can just, instead of going through what exactly they have to do or what's they're gonna find in a particular folder or something, they can just read the README that what we did in that particular task. Now, what are the results that we got? And these are the images. What are the findings we figured out? What are our notes or insights that we gathered? Everything is in the notebooks that we have uploaded. So just extract through those notes and put them on the README file. And this way we would have a very good README file for anyone who is coming and checking out our GitHub. So because this is something you would have to do. For example, if any employer is coming on your GitHub and they are checking out some of your projects, if you don't have a good README file, they don't know what to do. Even though you have a very good project, you are not presenting it well. So you need to work on for example, I can show you one that I created. Yes, that's not a good one, but still it covers everything. For example, for one of my projects, what I did is I kind of like put together all the things. So it's here. So here I'm guiding them where exactly they should go. And so it is in this folder, and now you can read. It is not a good one, but it covers everything. What exactly I did, what are the steps that we did, what are the results we got, and this is the second step, this is the third step, this is the fourth step I created. So which means if anybody is coming on this particular thing, they can read what exactly I did, what exactly my model is doing, because just by looking at the name, they don't know what exactly that is. So Readme would help in that manner. So our goal is not just to kind of like work on the project. Yes, we have, it's kind of like an end-to-end project, how to kind of like manage it on GitHub as well. Because if you're working in a team, in a particular company or something, many people are using GitHub, and you need to update the information on GitHub so that anybody who is coming and following along or something, or maybe coming later, what you did, they don't know what they did. So that's why when you're uploading something, for example, over here, you can see you write a good comments, and so that's a good practice on GitHub. So Readme is another way. I would recommend anybody who is not doing presentations, they can work on the Readme files for all the tasks that we did. And if you need any help in that, just let me know. I'm just telling you, you just copy paste the markdown sections from the notebooks, and that would be the initial start you can start with. And if you're struggling with how to put things like how to put a reference or how to put a figure or something like that, just let us know. I would just means anybody of us would be happy to help you out.
Yeah, and even if you need to put something together and you've volunteered, but you don't understand some of the concepts within our journey so far, just reach out. Me and Salman have got all the time in the world for this, so just let us know and we'll get back to you with what you need.
Thanks, guys. Any other questions, anyone? Any confusion?
Imran, just we want to reiterate for the people who are planning to present, what exactly is expected.
Yeah. And about the presentation format, have we decided any format?
Yeah, I'll be working on it and be sharing it very soon. Okay.
Yeah, on that I think Komal.
Yeah, can I share, Imran?
Yes, please.
Yeah.
I mean,
yeah. So just an example for the people who are going to present the topics out of these 9. So I'm talking about this topic. Suppose the univariate analysis for numerical variables, which I'm gonna take it. So when I'm taking this topic, I'm just talking about the numerical variables now. So we already have in our code what these guys have presented. 1 second. Suppose I'm talking about taking one of the variables like this. So I definitely need to know what these variable means, right? Kurtosis, mean, and all those things. So when I start the topic, I would want to myself study more about like how do I actually talk about this distribution, what all variables I need to know. So I will talk about the basic distribution, the basic terms, mean, mode, and kurtosis, and all this is in a theory format, which will be in the presentation. And then we will relate it to the code, which is already there with us. And also we can add on the new code and other graphs that are not covered till now. Like there were a few graphs Manasa has created, something on similar lines. So that's the second part that we are talking. The first part is I'm talking about the theory, what all these different fields meant to be. And second, I'm showing my own code. And third one is I'm adding on if there is additional that we explored and not currently included in the code. And that later, after talking with our task lead, we can just simply merge it to our GitHub. So everybody will have the same template, like the PPT template will be shared. You can create few sheets on your own depending on what you want to present. And at the end, we will merge them together to make one for our project. Does this make sense? Any doubts or any additions
So
we should
like
do?
presentation format, like we'll be talking about theory. So it will be like very generic, or it will be only specific to the code, whatever is covered.
Yeah, so like I said, it will be a generic theory too. If I'm talking about skew, mean, and so we will talk about what exactly they mean, give us a basic example, and we can relate that example with our with our code. Suppose I'm talking about kurtosis here. So I can simply show this map and tell that elevation has a quite big kurtosis, which is 8 or 9. What it means that it might have quite a number of outliers which we can clearly see. So in normal, we should have the kurtosis which is around 3. But anything which goes beyond 3 and above, we have to see how do we handle the outliers or something like this. So theory and relation with our code.
And theory will, if you think on a broader scale, like especially for interview guys or something, it's good to know the theory, so at least you can be more confident when you talk to your interviewer. So you're definitely helping yourself when doing this task. And there's nobody to judge. We all are learning here.
Yeah. So when I talk about, suppose I'm talking about kurtosis, like I said, one way is I can give a simple list and explain the kurtosis through that. And another and a better approach would be just take our data itself and show how exactly this is impacting our data and how exactly I can learn from a graph what is kurtosis and what it means for us. Does that answer? Yeah. Does that answer you?
Yeah. Thank you.
So
anything else that we should do, please suggest.
Yes, good point, Komal. Yes, please, anybody have any good idea, because we all are here to enhance our learning experience. So please suggest. This is just a framework which we try to share, but it can always be improved. We know that. So please share, ideally here right now, or otherwise post on chat, please.
Yeah, like I said, additionally, we can also add, like I asked Salman, like he said he did some feature engineering course which actually helped him. So whoever is presenting did some kind of course that helped helped in certain topics. They can also mention it in the PPT. I mean, just to give additional information about the particular topic,
Okay, we can do that, and rather it's a good idea at the end when we merge it, all the references can go at the end, which is references of websites or the courses or whatever. We can do that.
Yeah, we should definitely, I think, although there are some other codes or like the references which these guys share and some other people, so I guess we can make it more comprehensive, because the idea, we are not just restricting to this Omdina project, we are thinking for long run to so yes,
and there are a lot of courses in the market, so beginner it's really confusing for a lot of people, to actually select which is the best. So people who have already taken the courses and has benefited from the courses definitely can add up to the.
Yeah, I think presenting ideas in what we have planned is also a very powerful tool, because having technical skills is probably only about 50% of the job. In my experience, being like a data analyst for the past 10 years, it's
10 years. Wow.
It's for about 10 years, and that was just on data analytics. But a massive part of my job was not just gathering data and analyzing it and sending someone a technical report of insights that I've found. Sometimes a lot of the time you have to stand there in front of the high level stakeholders and explain your findings and explain what you found to people who not necessarily, they might not be as data literate as you, especially when CEOs and stuff, a lot of the time they don't have a solid grasp on the data. They have people to do that for them, so it's your job to explain that in an easy way. And doing these presentations and talking about things that you might not 100% understand, it not only benefits your public speaking and trying to transcribe your ideas in a way that makes sense to a non-literate audience, but it also helps with your learning as well. I'm not the greatest public speaker. I stutter. I'm not a teacher. You can tell the difference between the way Salman explains things and I explain things. It's completely different, and it is something that if you're not a teacher, if you haven't come from a university or a teaching background, it can be quite difficult. But the more you know things, the better you can explain them. And there's certain things that I can explain without even having a presentation. But when it's stuff that I'm not as used to, that's where I get a bit tongue-tied. But again, it's just practice. And a lot of the, I've been trying to, I've been moving over to the machine learning and AI for the past 2 years. Incorporated it with my job at the minute. I've only built small projects. I'm not building massive projects for like the likes of Google and stuff. They're relatively small. So this, has been a good opportunity because I'm the only person on my team who does that. I've got no one to talk to about it. And I see Omdina as a platform where I can get in front of people who I don't know and try and explain the concepts that I understand and I've implemented to people. So it's a learning curve in that sense for me. And doing stuff like this and presenting things that you're not 100% on is just a fantastic way of doing that. So, if you haven't volunteered yet, volunteer, and it'll pay back, a mass amount in the future for you, definitely.
For sure.
It's kind of like, for example, if you're presenting, think of it like you are kind of like answering one of the question in the interview, because right now you are not in front of an employer. Think of it us as giving you, so there are so many different people who would be giving you feedback, because these are kind of like what is the difference between kurtosis and skewness? How do you use it that is a common question. If you go and Google certain questions that are kind of like occur in a lot of data science interviews and everything, yes, these statistical terms comes very often, which means if you know what they are, right now this is the time for you to practice that interview section. So which means nobody is judging here. Everybody is on the learning path here. Everybody is learning, which means if you did not do anything right, we would give you a feedback so that you can improve. We would not pick on you. We would just give you a feedback so that you can be confident when you are kind of like talking to an employer during an interview and they're asking you these questions. So this will help you a lot. So the same thing with Rich. If you are kind of like alone on a particular thing and you don't have a person to talk to or something, it's kind of like what I was saying, that the more senses you use when you're explaining things, sometimes some people ask you a certain question, which makes you think about a particular topic in a way that you have previously not thought about. So that kind of like gives you more insight to that topic, and it gives you more in-depth kind of like ideas. Because previously, I never thought about that some questions would appear and how I would, for example, there is a question repeatedly asking in different, not just data science, in a lot of what is the difficulty that you face during a particular project and how you overcome it or something like that.
Yeah, they do ask, yes.
So this is a common question, which means by doing this particular project, now I know specific details that I got stuck in certain things during EDA and how I overcame it. So since I have a real life project happening right now, previously I was just doing individual projects and they were not pretty big. This one, we are trying so many different techniques. And when you try so many different techniques or things like that, you are troubleshooting a lot. And that troubleshooting would give you a good idea. So when, for example, in an interview, you're talking about certain thing and giving an example of when you got stuck something and got out from it, you would be giving a real life example. You would not be just making things up, and they would understand, because the other person, interviewer, they're experienced, and they can, just by at your story, they can understand how far along you were in that particular project. Means what exactly you were doing, whether you were stuck or you were just making it up or something like that. So they would understand it. So this is a good opportunity in this manner. Yeah.